Welcome, everyone. I really appreciate you joining us today and tuning in to learn about the Savannah River Priority Planning Toolkit and Landowner Survey results. I'm Lisa Lord. I'm the Conservation Programs Director with the Longleaf Alliance. And if you're not familiar with the Alliance, it's a regional conservation organization focused on restoring the longleaf pine ecosystem across 9 southeastern states. So part of my role with the Alliance is to provide staff support to the Savannah River Clean Water Fund, which I'll tell you more about in a few minutes. Just a few comments about the webinar. First, the webinar is being recorded. We will send a link to the webinar to everyone that registered when the webinar is over. And then we've also posted a link to the webinar, or we'll also post a link to the webinar on the Longleaf Alliance's website. Just give us a day or so to get the webinar posted. But the link to the priority map is already there. We do have everyone muted today, but comments are welcome anytime in the chat box. And then it would also be helpful for us to kind of separate the comments and questions. So feel free to put your comments in the chat box and then your questions for Alec in the Q&A box. And then I'll try to answer some of those questions during the presentation, but then we'll also have 10 to 15 minutes at the end of the webinar for questions. So the webinar itself will last about an hour. I'll provide some background for context on the Savannah River Clean Water Fund, and then I'll turn it over to Alec Nelson with UGA to go over the mapping product itself, and then the landowner survey results. So overall, this project really has 2 objectives. First, we wanted to develop a comprehensive conservation plan and map using the best available hydrological, environmental, and social data and analyses to identify those parcels that are the most critical to maintain in forested condition to support water quality in the basin. And then we also wanted to evaluate the qualities of landowners and their interest in various conservation opportunities like conservation easements and cost share programs. And many of you have been part of the planning process over the last two years. And then we have folks from other watersheds and states joining us. So just really welcome again to everyone. And if you're not working in the Savannah River Basin, I hope that you can learn more about how to incorporate water quality into your conservation planning process. Before we continue, I want to acknowledge the funding partners that have supported our work. So this specific project is a collaborative effort between the Savannah River Clean Water Fund, the University of Georgia's Warnell School of Forestry and Natural Resources, and the Center for Integrative Conservation Research and the Longleaf Alliance. Funding for this project was provided to the Savannah River Clean Water Fund through a U.S. Forest Service Landscape Scale Restoration Grant that was awarded to the Georgia and South Carolina Forestry Commissions, and a grant provided to the Nature Conservancy in South Carolina by International Paper. And this project would absolutely not have been possible without their support. So I want to provide a little background on the Savannah River Clean Water Fund. The Water Fund is a partnership that's focused on protecting the water supply for the communities and businesses along the Savannah River in both Georgia and South Carolina. Our vision is really that investing in forest today will ensure clean, reliable, and affordable water for generations to come. And so the overall goal of the Savannah River Clean Water Fund is to retain about 60% of the forest cover in the lower watershed. And so we do this primarily through land conservation, but also invest in restoration and support science and research. So our mission is to protect water quality in the lower Savannah River through bi-state collaboration. And so the Clean Water Fund serves as a leader, a champion, and a fundraiser for watershed projects that permanently conserve existing forests in the basin and that restore forests, agricultural lands, and develop lands to benefit water quality. So we work closely with our drinking water utilities, industries, forest partners, land trusts, private landowners, the Soloway Longleaf Partnership in South Carolina, and many other partners that work to conserve forests in the basin. The fund itself began in 2014 and is the only organization with a basin-wide approach to land protection focused around water quality. So we're working in both South Carolina and Georgia, the upper part of the lower basin and the lower part of the basin. And then we work with our land trust, our drinking water utility partners, many agencies, and our corporate partners. And together, the fund and our partners have contributed to almost 20,000 acres of land conservation in the basin since 2019. There are currently 5 utilities, upstream and downstream, that are participating or have participated in the fund. And then we also have as a partner International Paper, who is our first corporate partner. And then I provide staff support to the Clean Water Fund. And then we also work closely with the Forestry commissions, other agencies and organizations. So the Nature Conservancy helped to create the first watershed management priority index or parcel priority map for the Clean Water Fund. So the goal of this second priority conservation planning toolkit, version 2.0, is to improve our conservation outcomes or accelerate the number of forested acres that we conserve. So the first conservation map came out in 2014, and then this new conservation map utilizes new data layers and models that have become available since that time. We also have more of a focus on parcel connectivity and climate change in this new model, so it's much more forward looking. And we'll be using this conservation plan and information from the landowner survey to refine the partnership goals, desired outcomes, and priority areas, better align our funding with land conservation opportunities, find collaborative opportunities with new non-traditional partners, such as the industries that are in the basin, and identify high engagement opportunities with forest landowners. And this new map is also will be hosted online. And so we intend for this map to help our land conservation partners more easily match up land protection projects that have water quality benefits, assist our utility and industry partners to better connect green infrastructure and protecting the drinking water that they supply or use, and help our forestry and land management partners find landowners that are interested in engaging in these ways. So to learn more about the Savannah River Clean Water Fund and the Source Water Protection Partnership that we've developed, you can go to savannahrivercleanwater.org, or you can go to the Longleaf Alliance's website, longleafalliance.org. So now I would like to introduce Alec Nelson and turn the webinar over to him. Alec is a Ph.D. candidate in the Integrative Conservation Program and Warnell School of Forestry and Natural Resources at UGA. And today he'll present the results of his work to create this priority planning toolkit for the Clean Water Fund. And this collaboration with the fund is his primary PhD research project and the culmination of his studies in conservation decision-making, spatial design, and landscape ecology. So I will stop sharing my screen and let Alec take it away.
Great. Thank you so much, Lisa. And thank you all for being here today. I'm really looking forward to showing you the results of this work and the project that I've been doing over the last 2 years. As Lisa pointed out, this is a highly collaborative effort between many organizations and individuals, many of whom are in attendance today. So I want to extend a special thank you to all of the project partners and stakeholders who contributed to these projects in numerous ways. It couldn't be possible without you. So today I'm going to be covering an overview of the project background, the nature of the Savannah River and our conservation work there, and then covering the conservation priority planning exercise that we completed. Then I'll discuss the landowner survey that we did to evaluate landowner interest in these sort of conservation programs. And I'll also highlight a multi-method prioritization that we conducted, which allows us to combine the conservation and social priorities. And finally, I'll wrap up with some conclusions. So first, for those not familiar with the lower Savannah River, it runs between South Carolina and Georgia. And we focused on the lower Savannah area, which runs from Augusta to Savannah, is a largely rural 2.79 million acre watershed, a majority of which is forested. The entirety of the Savannah runs from the headwaters of the Blue Ridge through the upper Piedmont, and then a series of hydroelectric impoundments down to a free-flowing meander in the coastal plain. And it's one of the most hydrologically, ecologically, and historically important rivers of the southeastern United States, not least because it is the source of clean drinking water for over 500,000 folks in the area. There are a number of conservation concerns that are on the horizon or emerging in the area. And these include things like the effects of drought, sediment, nutrient, and chemical runoff, saltwater encroachment, increasing development pressure, and of course, climate change. To address these concerns, an approach that I've been really excited about and was excited to collaborate with Longleaf Alliance on was looking at green infrastructure. So to address these future drinking water supply demands and ongoing alterations, green infrastructure is an approach that conserves a network of forested habitat along the river, which promotes flood flow retention, nutrient and sediment trapping, and acts as a riparian buffer. A recent report published for the fund indicated that green infrastructure would significantly mitigate water quality changes related to several prominent nutrients of concern. This is paired with the fact that in recent years, there's been an increased interest in landowner to water protection. So connecting these forest landowners in the South, the majority of which are individual private family forest landowners, engaging them in conservation programs in order to promote this green infrastructure approach to conservation. So this is where the Savannah River Clean Water Fund comes in, as Lisa mentioned, promoting partnerships and land management programs within the watershed. As she stated, the goal of 60% forest retention. So this was the sort of state of the work going into it for me, and we began our conservation planning process, and I'll start with the mapping. So the priority mapping exercise that we did began all the way back in February of 2020 with our kickoff meeting. And this was followed by a series of stakeholder interviews, including some folks on this webinar today. Very helpful for me to understand the context of the work that's being done in the basin. Followed up with this by having discussions about the factors that were going to be included in the map, as well as the design of these priority products. And we went through a series of these meetings, design and feedback, consultation sessions, and then finally a deployment of the web mapping application, which I'll show you today in fall of 2021, and then delivery of final products this winter. So the process that we employed to create these maps focused on several objectives, which we defined beginning at the kickoff meeting, which you see here. First and foremost, we wanted to identify the most important characteristics of priority land protection in the watershed, and then map these priority areas such that we can identify high priority forest parcels for siting conservation engagement programs. And through this, supporting a strategic engagement with partners and landowners. So for my part, as a spatial scientist, I took these objectives and we summarized them into our problem statement for the mapping, which established our priority mapping goals. So the goal here was to identify which areas of forested land are the highest priority for protection and mitigation from urbanization based on potential impacts to water quality and availability. We took this to be our baseline analysis, that these are the key things that we wanted to learn from this process. In addition to that, based on stakeholder feedback, we decided to include 3 additional analysis objectives, which took that baseline and added additional components to it. And in the case of the latter 2 analysis objectives, brought in a whole new methodology in order to determine the effects of including future land use, a planning budget, and fragmentation reduction, all of which I'll show you today. So our spatial approach focused on selecting factors and having those factors define the spatial location of high priority areas. So factors are measurable and mappable components of the layered priority product that are known to be important for water quality outcomes. For example, land cover, riparian buffers, soil characteristics, and future urbanization all are known to have an effect on where water quality is promoted or hindered. Selecting factors is a challenging and iterative process. The things we want to pay attention to are minimizing the overlap between factors and therefore forming a complete picture where each factor is representing one unique component of the overall goal. And finally, that this is a process that we can refine over time, and we can also break up factors into different scenarios. You can see in the figure here that the factors act as a sort of intermediary between the raw spatial data itself and composing the goals of the project. In terms of the analysis, we conducted what's known as a watershed management priority index, where we classified each of the layers and calculated a weighted sum of the locations of each of these classified priorities. We then summarized this into priority groups based on natural breaks in the data in order to see where the highest priority areas are quite easily. We then reran this analysis to include future land use. That was our second analysis objective. And then finally, we developed a novel algorithmic optimization method, which allowed us to include analysis of planning budget and of fragmentation reduction. And I'll show you each of these today. So this is our chart for the baseline conservation priority index. I'm not going to go into great detail here, but the takeaway is that by selecting factors that allow us to characterize areas of greatest vulnerability to future change, such that these areas would affect water quality the most strongly, we identify the areas by classifying them to be a higher value on a 1 to 3 scale. And then we took these classified layers and combined them together in a weighted sum. The results look a little something like this. You can see on the map here, the colors correspond to values between 0 and 21, where the yellow is the low index value and the dark blue is the high index value. The areas that show no data were not prioritized based on either being a water location, urban site, or an area that is already protected. So it was not included in the analysis. Once we had that, we wanted to develop an additional analysis that took a look at future land use and climate change. And so to do this, we added on an additional factor using an EPA data set that projects future land use change and incorporates the expected effects of climate change in that model. And so we looked at areas where there was projected conversion from a natural land use to a non-natural land use or land cover within the next 30 years, and incorporated that into the same weighted sum analysis. We then rescaled the index to match the same index as the baseline, and then performed the same priority group summary. So with the first 2 analysis objectives completed, we then wanted to move on to the second 2. But our problem here was that we wanted to identify how to select a set of planning units, in this case, raster pixels, that consistently represent our planning goals when there are an enormous number of possible solution sets. The issue here is that we can't simply look at a stacked set of layers and individual pixel comparisons. We need to look at the entire data space in order to identify which set of pixels represent this best possible solution set. So how do we do that? Well, we went ahead and developed a method to algorithmically optimize and calculate what is that set of raster pixels that comprise an optimal solution, balancing our goals of representing each of these conservation priority index features versus a budget amount that we give the algorithm in order to most optimally select these pixels. We did this over a series of iterations, giving the algorithm 10% of the total budget in order to conserve the entire forest area, and then we iterated up 10, 20, 30, etc. From this, we could develop the same sort of index of, based on a restricted budget, where are the areas that are most high priority. The budget values come from this data set that you see on your right. These are estimates of private land value, fair market value, based on a recent report by Chris Milty, 2020. Once we had this analysis, we then completed an additional final analysis where we took a look at a method that reduces the prevalence of fragmentation in the solution set. We were concerned that an approach like this might generate sparse pixels, single pixels off on the side that may be high priority but aren't necessarily high connectivity to the rest of the solution. And so we applied a function that reduces the total boundary length, penalizing solutions that are highly fragmented and therefore promoting areas that are more continuous. And so that solution set has less fragmentation. So once we had these analyses, as I said, we summarized them into priority groups. So you can see here that baseline conservation priority index summarized into the 4 priority groups, low to highest. And again, certain areas were not prioritized. And once we had that, we could then summarize this analysis to the parcel level. This is a really key step because it allows our project partners to target and cite particular projects in particular areas if they know the relative priority value of each of these parcels. By the way, each of these parcels here are those that are above 100 acres in the watershed and are also not currently protected. Key takeaway from this analysis is that a majority of the highest and high priority areas along the Savannah River and tributaries, and then they also run along several of the wildlife management areas, which would promote connectivity of ecological sense. Let's compare this to the optimization algorithm, and we see that by comparison, it's a much sparser priority output. This is because the algorithm is more choosy than simply stacking the layers on top of each other. And it's really targeting the key sites that are both most optimal in terms of the feature representation and also meeting the budget. So the optimization algorithm significantly narrowed the focus, and this actually resulted in a higher efficiency compared to the baseline at targeting forested areas for conservation. So the optimization algorithm did a better job at picking those key forest areas. Quickly, I'll show you some results, some numbers here. So to compare these two main approaches, the baseline featured 75% of the total area was prioritized, with 47% of the total forested area being represented there. And then in terms of combining the highest and high priority, that ended up being 36% of the total watershed area, which was 32% of the total forested area in the watershed. By comparison with the optimization algorithm, this was closer to 41% of the total area represented in the priority analysis, with 35% of the total forested area occurring there. And then if we just look at highest and high priority, that's 20% of the total forested or total watershed area, with 19% of the total forested area. So you can see by comparing the highest and high priorities from both approaches that the optimization algorithm is capturing a greater percent of the forested area in that analysis relative to the total area that it's prioritizing. We also wanted to take a look at the budget in terms of what it would cost in theory to prioritize a certain percentage of the total watershed. The way we did this was we estimated the conservation cost and used our optimization algorithm to specify certain percentages of total forested land that must be represented in the solution, and identified what that optimal priority solution is, along with the total area and an estimated cost. We then converted this estimated cost into a estimated minimum cost to conserve that land, which was estimated at 30 to 50% of fair market value for the funding of a conservation easement. This is a rough estimate, but it does give us a ballpark figure for this sort of cost analysis. What we saw is that in order to conserve 60% of the forested land in the lower Savannah, based on our analysis, the priority planting solution would include 41% of the total area of the watershed and cost an estimated $3 to $4.5 million to conserve. This is, of course, likely an underestimate of actual costs because this analysis simply looks at individual raster pixels rather than taking into account costs of different parcels as entire parcel units. And future research would look at a parcel summarized cost estimates rather than individual pixels. The benefit of this approach, though, is that it accounts for differences in the relative cost of different areas of the watershed, rather than assuming a average acreage cost value across the entire watershed. So it's more specific. So key takeaways from this work: conservation priorities defined on the Watershed Management Priority Index and stakeholder feedback, and then presented both as priority groups and a parcel summary for the 4 analysis objective scenarios. The optimization algorithm that we used includes estimated planning budget, focuses the analysis to key priority areas of higher efficiency of represented forested areas, and by pursuing efforts on higher priority parcels, potential impacts to water quality and availability would be more effectively mitigated. If you'd like to take a look at this in more detail, we recommend that you take a look at the web mapping application that we've put together. This includes the layers that I just discussed, including a baseline and then each of the priority groups. There's a layer list there and a legend. And by turning on and off the layers, you can compare these different analysis objectives. There's also a handy function in the bottom left in order to print the map and share the web mapping application. There should also be a user guide available, which will give you more detailed instructions on how to use the web mapping application. All right, now let's turn our attention to the landowner survey. This was a project conducted in parallel, and it was focused on Southern Forest landowners. You can see here a recent report conducted by Dovetail Partners that looked specifically at landowners in Georgia. And this is a great resource for getting a much more in-depth understanding of the landowners in the area and various conservation programs and opportunities. But in summary, they say that the majority of forests in the South are owned by individual private owners, and they break down those landowners into 3 distinct categories. First is large acreage landowners. These folks have the greatest likelihood of engaging with timber markets and production, whereas moderate property owners view their land more as an investment than an opportunity for timber harvest. And then finally, the small landowners are more resident families and view their land more for recreation. So this is to say that there are distinctly different reasons for ownership, and that different size parcels tend to fall into these different categories. However, a vast majority of landowners across the acreage all say that it's critical to them that they are able to pass on their property to their heirs, and also to enjoy the natural beauty and scenery of the land. So we focused our project on the lower Savannah River Watershed of both Georgia and South Carolina, which is comprised of a patchwork of small forest parcels distributed between expansive clusters of moderately sized parcels and several large properties. So it really is a diverse area when it comes to understanding these landowners. So our study design had a couple goals. Firstly, we wanted to describe the conservation engagement potential of forest landowners with a series of conservation programs. And secondly, to identify strategies to connecting with representative landowner profiles, so different types of groups or different types of landowners. The way we went about doing this is we first identified what factors are most likely important to modeling landowners' willingness to engage in conservation programs. And then we deployed this survey following Dillman's The Tailored Design Method, which is an established method for conducting surveys over 3 phases. The first of which is a postcard, which you see in the top left there, which also included a link to an online survey that folks could take. Then we sent out a full mailing packet. This was to over 2,500 individuals. And then for those who we did not hear back from initially, we sent a full mailing packet as a follow-up. We were also fortunate enough to be able to include an incentive program. We had a raffle associated with the survey where folks had an opportunity to be randomly selected to win a very nice chainsaw as their prize for participation, which was really great. So we completed the landowner survey design and deployment over fall of 2020 and winter of 2021. I want to tell you a little bit about the various categories of questions that we had in the survey so you can get a sense of what we asked. The first section was about land and land management. So we wanted to understand the type of land that they had in terms of acreage, length of ownership, whether they resided there, what they did on their land, and whether or not they had management plans. We then wanted to ask about the sources of information, so ranking who are their key sources of information and what are any sort of barriers for engaging with conservation organizations. Then we asked them key questions about conservation programs. We wanted to measure their familiarity, participation, and interest in these different programs in order to get a sense of their willingness to engage. And you can see the programs that we asked about on your right. We followed that up with questions regarding their own reasons for owning their land, as well as their conservation orientation. So what type of landowner are they? What sort of environmental values or connections to local networks they have? And then we wanted to know their future concerns. What are those subjects that they're most worried about? And then finally, some demographics in order for us to contextualize these landowners. So we sent out the survey and we got back some really fantastic results. We had over a 25% response rate, which according to my colleagues here is really excellent. You can see our map here of completed survey responses. These are the approximate areas where we took their approximate locations and then mapped them in this sort of heat map analysis. And you can see the distribution is quite good. Note that for areas where you don't see as much, this may be a function of the fact that we sent these surveys to folks with at least 100 acres and based on our analysis that they owned a majority forested or wooded area. To create these sort of heat maps, we use an inverse distance weighting function in a GIS to model these neighborhoods, and the distribution looks quite good. So let's turn to the data now. You can see here one of our key questions for characterizing folks began with asking them what sort of activities they performed on their land. So a good number of folks said that they promote wildlife habitat, construct roads, and plant trees, whereas much fewer graze livestock or create forest products. In terms of their reasons for owning the land, top of the list there was legacy, followed by land investment. Privacy, nature, hunting, and recreation also ranked quite high, whereas timber, firewood, and non-timber ranked quite low. This is unsurprising given that only some landowners have enough land or have owned the land in order to gather timber. In terms of future concerns, some of the top concerns that folks had for the future included keeping their land intact, taxes, government regulation, privacy, vandalism, and protecting water. Lower concerns were subjects like damage from animals or climate change. I will note that these subjects are more divisive than they are highly not necessarily concerning. As you can see here, there's a real split between folks who were concerned and not at all concerned about these subjects. If we take a look at a comparison between Georgia and South Carolina, we can see there are some differences between these sets of landowners. We can see that Georgia respondents tended to have smaller properties with greater years of ownership. And if we look across both states, a majority of landowners do not rely on their wooded land for their income or have a conservation easement. A greater percentage of South Carolina landowners do not have their primary residence on their property, although they're more likely to have a second home on their property. And they're less likely than Georgia landowners to have a conservation easement on their property. When we turn our attention to these different conservation programs, we can see that with this chart here, this is for familiarity with these different programs. So the conservation use value assessment and conservation easements were the most highly ranked in terms of folks' familiarity, whereas certification or the current use program were quite low. We turn our attention to interest in the programs, we can see that across landowners, cost share and conservation use value assessment were quite high, whereas easements, current use program, and certification were on the lower end. I will say that conservation use value assessment and FOLPA are exclusive to Georgia programs. And so when you look at this breakdown between Georgia and South Carolina landowners, you can see that that is reflected in their familiarity and interest. If we take a look at heat maps, where we model this data out into space, we can see that the conservation use value assessment program, as I said, only being available in Georgia, shows that high, dark red, great interest focused more on the Georgia side. Whereas cost share programs and carbon capture programs and markets show a more even distribution with some interesting neighborhoods of high interest. On the lower end, we have the Forest Land Protection Act, again, a Georgia exclusive program, third-party forest certification, and conservation easements, which are a bit on the lower end of the interest scale. And you can see the neighborhoods of distributions throughout the watershed there. The final analysis that we wanted to do was take a look at representative landowner profiles. So what are the characteristics that are statistically similar based on a k-means cluster analysis? So what sets of data group different individuals together? We found this actually does break nicely into the same categories we heard about at the beginning, which include large acreage, multi-property, absentee landowners. So they're less likely to be residents of that property. They're more likely to take management stamps to promote their forested land. Then multi-acreage, multi-property resident landowners, so these are the moderate with woodland not especially important to their income. And then finally, small acreage, single property resident landowners, more likely to live on their land. You can see that's reflected in the map here, where the dark green is the large acreage multi-property absentee landowners and where they're located, the moderate green, and then the light green is the small landowners. So with this sort of breakdown, we can see where these folks are located, where they're clustering, and adapt different conservation programs to these different groups and have that be reflected in their locations. So in summary, for the landowner survey, we found that interest in programs appears to primarily be in the periphery of urban and developing areas further from the Savannah River. You can see on your right, this is our mean map of interest. So the average interest across all the programs, where is that located? and high mean interest is in red, so 3 or above. So you can see that located in neighborhoods a bit further away from the Savannah River, at least not the entirety of the Savannah River. Large acreage landowners, those over 1,000 acres, have the greatest interest in current programs, but we recommend that future programs should be developed with moderate or small acreage resident landowners in mind. This is because it is important to mitigate against the greater potential for forest loss among these landowners due to development and urbanization and the threats to their smaller parcels. So finally, as I mentioned at the top, we wanted to bring these two analyses together, and we performed a multi-method prioritization, which allows us to take a look at the overlap of conservation priorities and conservation opportunity to engage with landowners. So we've got our priority index on the left, and we broke that down into low priority and high priority, which is low to moderate priority assigned low, and high and highest priority assigned to be high. We did the same with landowner average interest. So we've got low mean interest and high mean interest. And then if you overlay the two of those, you can actually identify a multi-method prioritization, which shows in dark blue those areas that are both high conservation priority and have a high mean interest among landowners. And then you go down the series of colors all the way to yellow, which is both low priority and has a low mean interest in landowners. So in this way, we can distinguish between areas that are either high conservation priority or have high mean interest, and then identify the overlap between those two to really effectively target this sort of management action. You can see this overlap for yourself in the web mapping application. So I've added this conservation opportunity layer, this mean interest layer, into the web mapping application. And you can compare this by overlaying it over the conservation priority index. And if you'd like, you can use the transparency option to look at the overlaps. You can see here in this map, this is an overlap between that conservation opportunity landowner interest layer and the conservation priority index. You can see where these hotspots within the watershed. So wrapping up, we were very happy with the results of this work. We demonstrated the potential for landowner to water protection connection and management planning in the lower Savannah River watershed, and prepared a decision support toolkit and accompanying reports for identifying the trade-off between these different priority planning approaches. Future research in this arena would likely be focused on developing parcel level optimization methods to create portfolios of management options, particularly to look at different programmatic approaches and compare a wider range of existing and emerging conservation programs and strategies for their conservation benefits and opportunities. So I hope you found this webinar informative, and I look forward to taking any questions you might have. I do want to extend a thanks to everybody on this list and many more stakeholders, faculty, peers, and staff who volunteered their time and expertise. It was a real collaborative effort here, and I appreciate everybody along the way. So thank you so much.
Thank you, Alec. We have a couple questions for you, and then if we've got time, then I think you can walk these folks through the actual online map itself. Sure. But this question says, how can we replicate this game changer geospatial landowner survey by watersheds across South Carolina? So it could inform South Carolina Office of Resiliency in prioritizing their work. We know that forested wetlands and riparian corridors all have different threats, but landowner values are pretty consistent across the state and sharing a value of legacy. And if we save for water quality, flood storage, and carbon sink and groundwater recharge. So yeah, I'll let you kind of dive in there.
Yeah, great. Thank you so much for your question there. Yeah, this sort of analysis we think could be conducted in any similar watershed. The survey is not necessarily so specific to the Savannah River watershed that it could not be replicated elsewhere. And we hope to make the analysis that we've done available through a series of reports. You'll be able to see the survey that was done and the analysis that we did, and it's laid out in such a way that you could take those same sort of spatial inputs and the same sort of survey results and perform the same sort of analysis.
Great. So this question is asked for a little bit more in-depth information about the cost analysis. So it looks like it's implying a land cost of $2 to $4 per acre. Can you just explain that a little bit more in depth, and maybe what worked well with that particular analysis, and maybe what kind of information we need in the future to get a little bit more of an accurate estimation?
Right, great question. Thank you for that. So the values represented on that figure there of the cost is actually in log USD per hectare. So the values there aren't exactly going to map up to a dollar amount based on what you've seen there. I'll also note that the range of acreage cost vary quite widely across the watershed. And so it could be that the analysis is picking up those areas that are, based on this data, much lower cost, and then estimating it based on those amounts. In terms of future analysis, taking a look at parcel level summaries would be really valuable there, because it would give us a more specific parcel level dollar amount for that prioritization, and the prioritization would then be conducted weighing the different factors of parcel location, of area, of connectivity, and all of that. But that was just outside of the scope of this work.
Great. Let's see. Give folks another minute or two if there are any other questions. And then I will let you, if we can get this to work over Zoom, get technology to work here, I will let you pull up the online version of the map and kind of walk people through it.
Sure. Yeah, I'd be very happy to do that. So let me share this with you all. All right, so we see here, this is the web mapping application that we've put together. It is a raster viewer here in ArcGIS Online, and you can see our analysis there in the middle. We've got a legend here that shows the different priority groups. And if we wanted to take a look a little more specifically at the actual underlying index values, we could turn off this priority group layer and the layer list and turn on the baseline, where we can now see the actual index values based on that watershed management priority index. If we want to look instead at the planning budget, you could turn that on and see here, it's a much more sparse analysis, as I mentioned, but really focuses on just those high priority areas that are most optimal for our planning budget. And then finally, as I mentioned, we can overlay mean interest. So this top layer here, which has a transparency set that we can turn on by clicking on the dots on the side, going to transparency, and then adjusting the transparency of that layer. And using these tools, you can really zoom into a particular area and see, okay, there's some high priority land there, and also some high mean interest, which is that conservation opportunity. And so maybe that might be a space to focus management action. If you want to share any sort of analysis or viewing that you do in this web mapping application, you can use these tools down in the bottom left to print that map. So it takes your current extent, and you can select your format and some options about sort of size and scale, and then print that, and it should save onto your device as a PDF, which is really useful. And then if you want to share this whole map with other folks, you can find the sharing link right here. If there's any questions on that, I'd be happy to take those as well.
And I put a link to the map, and then Alec in the chat, and then Alec has also developed a really useful user guide that gives you some background information and more details on some of the things you might be able to find. So that's also in the chat. Any more questions? All right. Well, I will share my information here one more time. All right. This is my contact information. Most of you know how to get a hold of me anyway, but please check out the Clean Water Fund's website for more information, savannahrivercleanwater.org, or go to the Longleaf Alliance's website. And again, I just really appreciate everyone taking the time to join us today, and really thank all of the partners that have participated in this conservation planning process, that have contributed to some of the land conservation projects that we've been able to do, have funded these projects. Just really the whole community in both Georgia and South Carolina has supported the Clean Water Funds and the innovative work that we're doing together along the way. So just really appreciate it, and feel free to reach out to me or to Alec if you have any questions.
Thanks so much, everyone.